Thanks everyone for coming. Cool, so I'm gonna go ahead and get started. This talk is called Digging Up Code Graves in Ruby. So I'm gonna talk a bit about managing dead code and the complexity of it. I'll dive into some examples and talk about some tools for managing dead code and tracking dead code down in different Ruby projects and Rails code bases. So before I get into it, quick introduction. So I'm Noah. I work on the engineering team at Credit Karma. I love Ruby. I've been doing Ruby for a really long time. Most recently, I've been doing Scala. So happy to talk about the differences between the two after the talk as well. Cool. So technical debt. This is a term that probably most of you are pretty familiar with and have some experience with, and probably discuss with your teams on a regular basis. There's also something called code hygiene, which is probably a term that some of you have heard as well. Code hygiene is kind of an umbrella term for anything to do with the health and longevity of a code base. So this could be a variety of things. So this is kind of a visualization for technical debt and code hygiene. Technical debt can be many things that don't include code hygiene as well, but I'll mostly be talking about code hygiene today. So a few examples of code hygiene. So keeping dependencies up to date in your project. So for example, this could be the Ruby version of the project that you're working on or running, as well as the version of Postgres that you might be running, or any sort of dependencies or gems in your code base as well. So refactoring code is another common aspect of code hygiene, and it's something that's also frequently considered, technical debt. Many of us are writing Ruby in a fast-paced environment, working on Rails apps. So refactoring code is something that is important for good code hygiene and tackling technical debt. Documentation being accurate and complete. This is something that also is usually considered code hygiene, even though it's not actual code. Keeping documentation up to date for your REST APIs or internal documentation for any sort of projects inside your code base. And managing dead code is also considered code hygiene, what this talk is about. And many, many more. So there's probably many more examples that could be talked about that fit under code hygiene. Cool. So what about dead code? So dead code is another term that we may hear from time to time. We probably have a general idea of what this means. There are two distinct differences that I'm going to talk about today. So this is the Wikipedia definition. In computer programming, unreachable code is part of the source code that, or source code of which a program can never be executed because there exists no control flow path to the code from the rest of the program. Unreachable code is sometimes also called dead code, even though dead code may also refer to code that is executed but has no effect on the output of a program. So this is also kind of another visualization. So dead code is part of code hygiene, but also is a form of technical debt. So dead code, so the kind of latter aspect of that previous definition, executed code that is never used in a program or code base. So this is kind of a simple example. So if you have an add function that takes two arguments to add two numbers together, clearly that second line there is considered dead code. Not unreachable since it is run, so that's the distinction there between dead code and what's also called unreachable code. While this is a pretty harmless example, consider in a larger application, instead of this z equals x, we might be making some network call or doing some expensive operation that could cause the user to wait unnecessarily. So the second aspect of dead code is unreachable code. So code that's referenced but will never deterministically never be run. There's kind of a variety of unreachable cases or code that's unreachable. So if you have logical errors in conditional statements, so also a simple example, this is probably considered a bug to most people, but consider a case maybe where my number is not a hard-coded value, and we're getting some data from a remote source, and we never execute call my method because we simply or the if condition is simply never true. So another case is code that was left intact for the purpose of preservation. So if you have some code that's unreachable but has been left around just for kind of documentation purposes, this is probably not very useful. Git is an awesome tool that works pretty well for that. Data used in a conditional statement that never causes a true or false evaluation. So here's an example of that. So if we have a method that calls some external service, could be a database, could be an external API, could be an internal API, and we get back a result, and we check that result, and we call a method. But if that result isn't truthy, then we call my other method. Also a contrived example, but in this case, this could be an example where there may be some dead code if result is always truthy or always falsy, and maybe at some point that wasn't the case, but it's not obvious to the reader originally. So feature toggles are also another common case of dead code that can be introduced into your code base. So they've become kind of a common practice for canary testing, A/B testing, dark deploying, operational testing, and they're great for being able to iterate quickly on a product for quantitative or qualitative measurement. However, the downside of adopting them pushes cost onto development. So there are many ways of implementing them, some as simple as a table in your relational database and a simple class or wrapper around querying for the state of various toggles. There are also third-party services available for accomplishing this that can provide great UIs for toggling features. Many companies will also invest in internal tooling for this kind of functionality. A few of the most common strategies I've seen for using them are at the edge. So using them in maybe your front-end code or your front-end application to toggle button color or copy or things of that nature. If you're using them across the stack, so you're also using them to toggle internal implementation details or internal implementation behavior, you could potentially have dead code as a result of this across the stack. So a few of the pros and cons of using feature toggles. So one benefit is you can pretty much say goodbye to feature branches. You can merge branches behind a feature toggle or a feature flag. It's also called dark deploying. So if you have some feature that a team is working on, you can kind of build the shell of that feature, deploy it to production, and iterate on it in production. Another benefit is it enables the agile philosophy. So you can release experimental features to a small user base, and instead of building something that's larger upfront. It also can give control of product functionality to stakeholders. So an example of that would be if there's a product manager on your team or project manager on your team, they can control the state of the product from a panel that's shared, which has the various states of different flags in your project. So it also allows for segmenting feature variations across your product, which allows for A/B testing, which can provide insight into optimal UX, what your users like better, what experience they prefer, and what experience converts better. So some of the cons, so as mentioned, it can be a significant source of dead code in the form of potentially unreachable code, which carries costs with it. It requires maintaining backwards compatibility in all code changes. So if you're migrating from one way of doing something in your code base to another way of doing something, you probably need to and want to maintain backwards compatibility between both those versions to support them if you potentially turn a flag or a feature toggle off or on. It can introduce fragmented states across environments if environments are not kept in sync with the status of a toggle or a flag. So what I mean by that is if you have multiple environments for your application, such as production, QA, development, you might have different flags that have different states set across different environments. So you're seeing different experiences while testing your application in one environment or developing your application in one environment. Testing complexity. So in your unit tests and your integration tests, you probably want to maintain any tests that test existing behavior and new behavior that you're introducing behind a toggle. So that carries costs with it as well. So let's look at an example in code. So here's a fairly large example, so I'll try and break it down. So let's pretend we're building a system for grading a transcript. So we have a transcript class there at the bottom. That transcript class takes a list of letters, grade letters, and then it maps over them and builds up a collection of grade objects. Each of those grade objects has a public, or that grade class has a public instance method points, which will return the point value for each grade. And then the average API on the transcript class will sum up each grade point or each grade and give you a point value, and then divide by the total amount of grades that you have. So here's kind of a second example that we've expanded here. So say we want to support letter grades with plus and minus and the associated point values there. So this is also kind of large, so I'm going to break it down slide by slide. So firstly, we added the letter grades with the plus and minus point values and letter grades themselves. Secondly, we added a generic keyword argument to the points method. And what that does is, if it's generic, it looks at the first letter or the first character, the 0th character, in the grade instance variable value. Otherwise, it uses the entire value, which will include the plus or minus. And then lastly, we changed the transcript average API, which will pass through the generic argument, which is passed through to it. So that will give us either generic or non-generic grade point average. So here's that example altogether. So here's how we might use that implementation. So we will instantiate a transcript. We'll pass through some grades to it, and those will get mapped to grade objects. Secondly, we'll grab the feature toggle value for which grading strategy we want to use. So we're imagining that there's a front end for this application, and we're changing the grading strategy based on testing which strategy is desired for the user. So we'll check the value of that toggle. If it's generic, then we'll call the transcript average API or method without any arguments. If it's not generic, then we fall back onto passing through generic false, which will use the plus and minus grade point values. So what's the issue here? So this implementation supports two behaviors. Probably could use some sort of abstraction, and there could be separate strategies or separate classes for doing those calculations. But let's assume that this code was supported for being able to test multiple variations of a feature for which feature we'd like to, or for which scoring strategy we'd like to proceed with. So in that case, the internal implementation doesn't have any know-how or knowing of the fact that it's being tested. It's passed through via the generic keyword argument. So eventually, if this code here was only hitting the generic calculation snippet, then the case where we're doing the more complex calculation or advanced calculation would be dead code, and vice versa. So if we decided that eventually we're only going to calculate with the plus and minus letter grades, then the simple calculation or generic calculation would become redundant. So another way of doing this would be to have the internal implementation know about the feature toggle, but then we would be coupling the feature toggle to the internal implementation. So we need to kind of understand the variations either from the internal implementation or from the values being passed through to it. So now I'll talk about some strategies for managing dead code. So in a case like this, so there's this really unique and experimental library in the Ruby standard library called Coverage. It's a lightweight tool for tracking code paths in larger code bases. So here's the official documentation on it. It's pretty sparse. So here's the example from the Ruby docs. I'll break this down. So s equals 0, it's setting s equal to 0 and then looping over 10 times and incrementing the value of s with x in each iteration. And then it's checking if the value is equal to 45 and outputting the OK symbol. So the output is here down at the bottom. So we can see that array, that's what coverage gives us. So coverage is telling us that line 0 or line 1 was ran once, and line 2 was ran once, and line 3 was ran 10 times, and so forth. Anywhere that coverage outputs nil, that means that it's a line that there was no code that coverage could tell us about. So an example of that would be end or an empty line. So that's why you see nil there for the last end and the first end, as well as the empty line. So it's kind of hard to understand at first without the actual line numbers. So here's an example of that code snippet with some pretty printing. So lines, this basically converted the output from coverage into a hash instead of an array. And the indices in that array indicate the line number in the code. So this is telling us each line and how many times it was ran. So coverage can be used for, in larger examples, you can use it for having the Ruby VM tell you which lines of code it ran. So you can pass through different values. In the grading example, you could pass through generic true or generic false and look at the output from coverage. And coverage will tell you which lines the VM ran and how many times. So you can see if there are some lines that were expected to be run or weren't expected to be run and were, coverage will tell you that. So coverage can be useful for testing different variations of code paths that maybe aren't used anymore. So another strategy for managing dead code, warning and or logging by the experimentation platform or feature toggling platform that's being used. When a given experiment or feature toggle has been alive for some period of time and targeting 100% of traffic. So if you have a feature flag or a feature toggle or an experiment that has been running for a long time and it's been at 100% of traffic, then you know that in your code base, it's likely that the old variation is no longer needed and is probably dead code. So some experimentation platforms give this to you. If you're using your own lightweight implementation, you could build this into whatever you are using. So there's also this really neat tool by Searls called To Do or Die. It might be a bit too much, but this is a way to comment or augment your code with To Do or Die calls, and you can add a comment and a date, and this will tell your application to log or warn or even crash if some date has passed, and that comment is still there. So this can be useful for maybe personal projects or even production projects, but you'll probably want to log or warn in production rather than crash. So, and then you could crash in pre-production environments, similar to what DB Migrate does in development. So another strategy, this is less technical and more organizational, would be to add a requirement to whatever project initially introduced the new code or new functionality, add a requirement to that project to come back and evaluate any old code that may still exist due to the new functionality that was introduced and tested or experimented on. So what if I do nothing? So what if we never cleaned up dead code and we just let it exist in our code bases? Technically, that may not break anything in and by itself, but there are costs associated with that, and you might end up feeling like this. So you might feel like everything is fine, but eventually you'll realize that it's becoming increasingly difficult to work in a code base like that. So some of the costs associated with ignoring dead code or ignoring unreachable code could be wasted cycles in your application that causes a user to wait unnecessarily. So this could be an external API call that's not needed, or a database query that's not needed. It makes onboarding engineers onto a project increasingly difficult when there are large portions of the project that are relics. So if you have a new engineer joining the team, jumping into the code base, and there are lots of portions of the code base or implementation that are no longer used or no longer executed, it becomes increasingly difficult to manage that. Maintaining it by way of updating unit tests due to tangential changes, or supporting it without knowing it's unused, has costs associated with it as well. So if you make some change and some portion of dead code breaks, and you have to update, or their tests break due to some other unrelated change, you may find yourself updating tests for dead code just because the dead code itself hasn't been removed, and that might be the path of least resistance. So that's also kind of another downside of maintaining old dead code. So this is a great quote, and Martin Fowler also has a great article on the cost of feature toggles, but the way he put it was, savvy teams view their feature toggles as inventory, which comes with a carrying cost, and work to keep that inventory low, as low as possible. So that's a great quote from him, viewing dead code and as a result of feature toggles or otherwise as inventory, and the cost of that inventory can be significant. So that's all I have for today. I'll be taking questions afterward off stage, so thanks everyone.